one more systems of equations word problem, but with just two constraints. And a constraint is kind of similar to what we created before, where you have like a certain boundaries, like x plus y is less than 40, or like x is greater than 10, or something. These would be considered constraints. So let us begin. Now, if you saw the other videos, I strongly recommend that you at least try to pause the video and that you try to create the system of inequalities. And if you're able to do that, right, and you check it and you get it right and stuff, pause it again and then try to put it in slope intercept form to graph. That way, at least you know that those are two things that you are very good at, and that's really the foundation of understanding how to solve these. Okay, so Luca is buying balloons for a party. Latex balloons cost $1.50 each, and plastic balloons cost $4 each. He has to spend less than $30, but wants to have at least four plastic balloons. What system of inequalities would model this situation? Okay, so we should start off by creating some variables, all right? And what are the variables that we're working with? And it's a little too thick. I'm gonna erase this and just make something a little smaller. Okay, so what are the variables that we're working with? Okay, we can have let x equals and we can have a let y equals. Okay, the reason why I use x and y is because especially when you're graphing, you have to like label these. Now in this case, I just realized that they actually labeled them on the bottom. So being that this is the x-axis, um, and we have a let x equals, that would actually mean that this is the number of latex balloons, okay? And that kind of makes sense because we're talking about two different types of balloons, and this is the number of plastic balloons. Great, so now we have this. Now we need to actually create our stuff. O and S, okay. So let's see, what do we know? I would probably underline or annotate some things. So Luca is buying balloons for a party. Great, not really that important, but we do know that latex balloons cost $1.50 each, okay, and plastic balloons cost $4 each. Okay, good. So those are units. Those are monetary units, so they're about money. All right. Then we have another thing here that says he needs to spend less than $30. So it's another monetary unit right there, dollars, and he wants to have at least four plastic balloons. Awesome. So to create our stuff, we need to find any totals. So I'm seeing a lot of things with money here, and out of these three, the less than 30 is going to be our first inequality. So our first inequality will be about money. Okay, everything on this line will be about money. So we have the total, we're going to put less than 30, okay? And what makes up this $30? Right, he's walking into the store. He wants to get these balloons, and there are certain prices for these types of balloons. So if I had just said that, x, well, x represents the number of latex balloons, but it doesn't represent the amount of cost for the latex balloons. But we do know that they're $1.50 for each one, and we know that it's $4 for each plastic balloon, right? Remember, this represents the number of plastic balloons. So the more that you buy, the more you're going to pay for them. So if y was 5, that means he wants 5 plastic balloons, each costing $4. So this would be $20 if y was 5. So this tells you the total amount for each type of balloon, and he wants to make sure that when he adds up that total, it's less than $30. Then he says he wants to have at least 4 plastic balloons. Okay, now very important here, and this is the hard part, is that you have to identify what is being asked. So here, or stated here, when it says less than 30, less than 30 is the amount of money made up between buying both balloons. In this one, it's only talking about one statement or one fact, and that fact is that he needs to have at least 4 plastic balloons. So at least means greater than 4. And the only thing that we need is to worry about is just plastic balloons, and that is the variable y. So there's no reason to include x here, because that total or that fact that he needs at least 4 doesn't involve the use of latex balloons, only plastic. So these will be our two inequalities, and we need to graph this. So the way that we would do this is we will have to set this into y equals mx plus b form, and I think that you should pause this and make sure that you are really good at getting that into y equals mx plus b form. So I will write it here, plus 4y. Okay, I'm not going to write 4.00. I could just write 4y less than 30. And if we were to go ahead and solve this, subtract 1.5x, subtract 1.5x, this then becomes 4y is less than, we're going to write the negative 1.50x first, plus 30. Okay, then from there, we just need to solve for the y by dividing each term by 4. Okay, so this cancels out. And this actually ends up being, let me just put this in my calculator because I'm not too sure. 1.50 divided by 4, oh, JK, hold on, divided by 4 is 0.375. So I know that that is approximately, that's, is that 5/8? Let me see, I forgot what that was. Nope, I think it's 3/8 maybe. Yeah, 3/8, that's what I thought. Okay, plus, and then 30 divided by 4, okay, is going to be 7.5. So not the best number, I guess. It's like, it's kind of, yeah, it's not that great actually. It's gonna kind of suck when we graph. That's okay. It is what it is, right? So we're gonna start at 7.5. So let's see, 2, 4, 6. Here's 7. So 7.5 is right there. We're starting right there. Okay, now it's a little interesting now. You got to be careful with this. We're going to go down 3. So when I go down 3, this is not considered 1. Okay, I'm going down 3 whole units. So 1, 2, 3. Okay, so we'll do that again really quickly. So if I start halfway, then down here would be 1. Okay, halfway. So 1, 2, 3, and then we move over 8, like this. Okay, and that is a less than sign. So we're going to be shading below, but it's also a dotted line, and we're going to have to make sure that we put a nice dotted line there. So let me see, can I grab that? Oh, nope, can't do that. And gonna go ahead and just shade below. Okay, because it's a less than sign, so we're shading below the line. Okay, and the other one now is y is greater than or equal to 4. So if you remember, the graph of y greater than 4 is actually a horizontal line that passes through 4. But something very specific about this is that this is a greater than sign and it's a dotted line. So we have to make sure that we put a dotted line there and not anything else. So go ahead and just do that like right there. Okay, so we have 2 dotted lines altogether, and we're doing anything greater than that. So here's the y. Where would you find the y values that are greater than 4? They would be above. So we're going to go ahead and just shade, right? Just shade them all in. And what we're looking for is where they overlap. So here, you're going to see right in this little like triangular area here, this is the area where they overlap. Anything here. So any point inside of that triangle, that would be considered a solution. Okay, and we can actually just take a second and just do that, and so we can show you where that is. Now I'm just going to put a random dot, I don't care where it is, and put it right here. Okay, so what is this? 2 comma what is this, 5? So I'm going to put 2 comma 5. Okay, now 2 comma 5 is more than just a coordinate. It actually means something. It means something because this 2 represents an x and this 5 represents a y. And if we go back to the top, this is the number of latex balloons. So he's saying that if he goes in, he buys 2 latex balloons and 5 plastic balloons, okay, is this acceptable? And we'll know if it's acceptable if it meets the constraints, and these are the 2 constraints. The first constraint was that when you purchase everything, you can't spend more than $30, and the second constraint is that you had to have more than 5 plastic balloons. So we're going to test that constraint right over here. We're going to go ahead and I'm just going to write the coordinate here, 2 comma 5. Okay, again, just writing an x and a y there, and we're going to substitute them into our inequalities that we made. So plus 4y is less than 30. So we'll start with the first one, $1.50, okay, for 2 latex balloons, x is 2, plus 4. So if you bought 5 what was this, plastic balloons, is that less than 30? So let's see, 2.5, I'm sorry, 1.5 times 2 is 3, plus 20 should be less than 30. And 23 is definitely less than 30. This is absolutely true, okay? But just because it's true for one doesn't mean anything. It has to be true for both of them. So if we go to the other equation that we have, this other constraint was just that y had to be greater than 4. Well, that's easy because we have that y was 5, and 5 is obviously greater than 4, so this is true. So what this means is that if he goes to the store and he buys 2 latex balloons and he buys 5 plastic balloons, this is acceptable because he doesn't go over budget, and he still gets at least the number of plastic balloons that he needed. Now that's not the only answer, okay? He could go in, he could literally get five, is this 5? He can get 5 latex and 5 plastics, or he can go and he can get 1 latex balloon and 6 plastic balloons, right? These are all combinations. Each coordinate is a combination of items that he can get and still be under budget and still have the number of plastic balloons that he needs. Okay, so that is how that would work. The next example that we're going to do is something that has 3 constraints, so it's a little bit more, and I know that the hard part is identifying like what those constraints are, so hopefully these videos will help you.